This was stumping some of you, my friends. And when we create an area model, our entire goal is to divide this rectangle up by using easy numbers to multiply with. And that would be using tens. Then we can do the math in our head. Anytime we multiply by a 10, we can do the zero math trick. Okay, so in this case, when I'm looking at 24 times 7, I would first want to model the original problem. Okay, so I could take this square, and I know that the area model is using the formula for area, which is area equals length times width. You guys remember that? So I could take the original amount, and that little symbol there is the same as a multiplication symbol. So I could say, well, the full length of this rectangle is 24. And then the full width of this rectangle is 7. Okay, and that would tell me the area, the two-dimensional area of this rectangle here. Now, if I needed to make life easier so I could do math in my head, I could look at this 24 and say, well, let's make this easy. Let's work with tens. And there is, in this column, a 2 representing 2 tens, which is the same as 20. And if I, instead of 24 times 7, say, well, 20 times 7, then I still need to account for what's left over. And what's left over is a 4 in the ones column. And I could also then say 4 times 7. So if I broke it up like that, 20 times 7 plus 4 times 7, it's the same as saying 24 times 7. And yet then I could probably do that math in my head. However, you also need to know how to model it. So instead of the 24, I'm going to break this 24 down into tens and say 20. And what's left over is the 4. And then my 7, my multiplier, stays the same. So what I would be doing is I'd be breaking down this model. And then this portion of the model, the length is 20. So 20 times the width of 7. And then this remaining length is 4. And guess what? The width stays the same whether I'm on that side or that side. So times 7. And then I would just solve for that. And I know instantly that 7 times 2 is 14. So I get 140, right? The 0 times 7 gives me 0. 7 times 4 is 28. So then my last step is to add those two amounts together. 140 plus 28. And again, it should be pretty much math I can do in my head. And so I know the total area is 168. Now again, I could definitely do the 24 times 7, and I would end up with the same answer, 168. But the goal is to be able to model it. And that comes in really handy next chapter when we're doing multi-digit multiplication. Okay, so here is a problem that is very similar to something on our math exam. And if you can hear Kira and Kai in the background, you can say hi to those nerdy Nawg-Dawgs right now. But here's an example. It says, Kira goes to music class once a week. She attends on the same day each week. Kai goes to music class every other day, and they both were at music class on the 12th. When will they be at the music class again on the same day? So I made a copy of a little calendar here, if you can see that. And we know that they were both there on the 12th. So I'm going to use the purple pen for Kira and the red for Kai. But if Kira goes to music once a week and she goes the same day each week, then we know that Kira is there this Thursday. She'll be here this Thursday. She goes the same day every week. Now it says Kai goes every other day. So if they both happen to be here on the 12th, we could start with Kai on that date. Every other day means he doesn't go the next day, but he goes the following day. Then he doesn't go the next day, but he goes the following day. Then he doesn't go the next day, but he goes the following day. Oh, he doesn't meet her there. So when will they be there together? And this is one way in which you could solve for, oh, looky there. They both will attend music class together on the 26th. Okay? That is one way that you could solve for that. Another way would be to look at the multiples, right? If Kira goes every 7 days, you could do it that way. Whereas if Kai goes every other day, that would be every 2 days, right? So you'd have to see how long till they meet up again. But having a calendar makes it really easy to draw it out like that. Okay, last question, very similar to what's on our test. It says, what is the estimated quotient of 84, this is a symbol for division, divided by 6? And here's the thing. If we still don't know division, and again, we don't get to it until the end of chapter 3, we can use what we know about multiplication. Remember, our fact families. Okay, so if I have 84, and I know that when I divide it by 6, I will have the answer that belongs on that side. If I don't know division, there's another way I can solve. And I can take what I know about 6 times something and come up with an answer. So maybe I just need a jumping off spot and I say, well, how about 6 times 10? That equals 60. That's not quite big enough, right? So what if I then go to 6 and I need to set it up this way? 6 times 15. Well, 6 times 5 is 30. Carry my 3 that represents my 10. 6 plus 3, 90. Oh, that's too high. So now I know my number has to be between 15 and 10 because 60 was too low, 90 is too high. So maybe I'm just going to try 6 times, what's in between? How about 14? 6 times 4 is 24. 6 times 1 plus 2, 84. Oh, lo and behold, answer found. So now I know 14 is the answer because 6 times 14 equals 84. Fact family, just like 84 divided by 6 equals 14, or 84 divided by 14 equals 6. So you use what you know about multiplication to solve. Now in this case, it says the estimated quotient. So how could I make this easier? Well, I could, let's see. And I don't know why I put these answers in here. I was looking for something else. Or I had something else planned originally and didn't change that. But if I had to estimate, I could always go with 80 divided by 6, right? And then that would make it a lot easier because I'd instantly go to my 6 times 10 and my 90, so I'd be working with 10s. So again, it's all about using compatible numbers to help you solve. All right, nerdy Nawg-Dawgs, I hope that gives you an idea as to what's on the test. Study hard.